Okay, let's see more examples using substitutions. Again, these examples are still review from the integrals from Calc 1. So in the next example that we are going to use the substitution, we have the indefinite integral of cosine of 5x. If it was only cosine of x, that was much easier because antiderivative of cosine is sine. But here it's not cosine of just x, it's cosine of 5x. So we need a substitution here. And the substitution that we use here is u equals 5x. Now the derivative of u with respect to x is 5, meaning that 5, if I write 5 as 5 over 1 and by cross multiplication, 5 dx equals du, or du equals 5 dx. So in this integral, 5x was taken as the new variable u, and du is 5 dx. I don't have 5 dx here, I have just dx. So if in this equality here, if I divide both sides by 5, dx is du over 5. So this dx here is the same as du over 5. So let's see what we have so far. We have cosine integral of cosine of u du over 5. Over 5 is like 1/5 has been multiplied by the rest of the function, so that can be pulled out as a constant. And integral of cosine u du. An antiderivative of cosine u is sine u, so 1/5 sine u, and then plus c, because we are dealing with an indefinite integral. One more step, we need to do the back substitution. U is the same as 5x. So if I want to go back to the original variable x, that's going to be 1/5 sine of 5x and then plus c. That's the answer that we type in here. Try the next example on your own before you watch my solution, the integral of sine of 10x dx. As you might have figured out, we let u be 10x. So I take 10x as the new variable u. The derivative of u with respect to x is 10. In other words, du is 10 times dx. Here I only have dx, not 10 dx. So if in this equation I divide both sides by 10, I'm able to solve for dx and write dx in terms of du over 10. So here we have the integral of sine of u du over 10. Again, over 10 is like 1/10 has been multiplied by the rest of the function, can be pulled out. So 1/10. Antiderivative of sine is negative cosine, right? Minus cosine of u and then plus c. So 1/10 times that's negative cosine is minus 1/10 cosine of u. but we need to go back to the original variable, knowing that u is 10x. So this is going to be minus 1/10 cosine of 10x plus c. So minus 1/10 cosine of 10x plus c. Let's do another example. The integral of e to the power of 3x dx. If it were just e to the power of x, it was much easier, but here we have e to the power of 3x. Please try this on your own before watching my solution. So the exponent here is 3x. Let's let u be 3x. So let u be 3x. The derivative of u with respect to x is 3. In other words, du is 3 times dx. So this exponent is the same as the new variable u, but I need to know what is dx in terms of du. In the last equation inside this rectangle, if I divide both sides by 3, it gives me dx in terms of du. It is du over 3. So this dx is du over 3, meaning that I will have the integral of e to the u du over 3. Over 3 is like 1/3 has been multiplied by the function, so I pull that out, and the integral of eu du. As you know from Calc 1, and also I made a reminder in a previous video, antiderivative of e to the u is e to the u. Since it's an indefinite integral, that's going to be plus c at the end. The remaining step is just a back substitution. I replace u by 3x because u equals 3x. So here it is 1/3 e to the power of 3x plus c. So I need to point out that if we have a definite integral, again, that's another reminder of from calculus 1. So again, you have seen these kind of integrals in Calc 1. If we have a definite integral that requires substitution, we don't need to go back to the original variable. Instead, we change the limits of the integral according to the substitution. So to clarify that and remind you how we dealt with these kind of things in Calc 1, let me do this example. So I have a definite integral, suppose integral from 0 to 1 of 2x times x squared plus 3 to the power of 5 dx. And at the end, I need an exact value for this. This is like similar to one of the examples that we have done before that required substitution. Do you remember for this integral what was taken as u? U is x squared plus 3. And du over dx, or the derivative of u with respect to x, is 2x. In other words, du is 2x dx. So inside this parentheses, we took it as u, and 2x dx is du. So integral becomes u to the 5 du. Now here it comes the important step of figuring out what are the new limits of the integral. In the original problem, that 0, 1 correspond to x. So x runs from 0 to 1. Now I need to know that as x runs from 0 to 1, u runs from what to what? That relationship between u and x is given by this equality. Look at here, u is, let me focus on that, u is x squared plus 3. So look at the lower limit of the integral, 0. When x is 0, u is what? Is 0 squared, it's x squared plus 3. So it is 3. So the lower limit of the integral becomes 3. How about the upper limit of the integral? That's 1 up there. When x is 1, u is 1 squared plus 3, which becomes 4. So that upper limit is 4. For the definite integral, I don't need to go back to x, because eventually I find a number. Antiderivative of u to the 5 is u to the 6 over 6, and it should be evaluated at these values, and we should do the subtraction. This means that this equals the evaluation of this function at 4, which means 4 to the 6 over 6, and minus the evaluation of this function at 3, 3 to the 6 over 6. Common denominator is 6. 4 to the 6 minus 3 to the 6 is going to be 3,367. And this cannot be simplified more, so that's the exact value of this integral. Let me do another example of the definite integrals involving the substitution methods. The definite integral from 1 to 3 of 12e to the power of 4x dx. And I want to find the exact value of this. Please pause the video and try to do this on your own before watching my solution. What did you take as u, as the new variable u? Obviously, the answer is 4x, because the exponent of e is 4x. The derivative of u with respect to x is 4, which gives me du is 4 dx. Or if I want to solve dx in terms of du, by dividing both sides by 4, dx is du over 4. So let's see what we have so far. This is the new variable u, and dx is the same as du over 4. Twelve is a constant multiplied by the rest of the function comes out. 1/4, or this 4 in the denominator, also comes out. So 12 over 4, 12 and 4, they come out. 12 on the top, 4 at the bottom. And then the rest of the function, we have e to the power of u du. What limits for the integral did you come up with? Again, remember that in this example, u is related to x by this equality. U is 4x. So when x is 1, the lower limit of the integral, when x is 1, u is 4 times 1, which is 4. And when x is 3, the upper limit of the integral, u is 4 times 3, 12. So these question marks, the lower limit of the integral is 4. The upper limit of integral is 12. Okay, now let's do this. First of all, 12 over 4 is 3. So 3 antiderivative of e to the u is e to the u and should be evaluated at the limits of the integral. The evaluation of this function at 12 is what? 3 e to the power of 12 minus the evaluation of this function at 4, 3 e to the power of 4. And that's the exact value of this integral. So the value that we need to type in here is 3e to the 12 minus 3e to the 4. Let me also do a trigonometric example of a definite integral involving substitution. Again, please try this on your own before watching my solution here. The integral from 0 to pi over 8 of cosine of 4x dx. What substitution are you suggesting? U equals 4x is the correct answer. And the derivative of u with respect to x is 4. Or cross multiplication, du equals 4 dx. If I want to solve for dx, divide both sides by 4. Du over 4 is dx. So let's see what we have so far here. I need to change the limits of the integral according to substitution. 4x is the new variable u, so it is cosine of u, and that dx is du over 4. Now, what about the limits of the integral? When x is 0, what is u? U is 4 times x. So when x is 0, 4 times 0 is still 0. Or let me discuss it here. So u is For x, when x is 0, u is 4 times 0, still 0. And when x is pi over 8, u is 4 times pi over 8, which is pi over 2, right? 4 over 8 is 1/2, and there was a pi there, so 4 times pi over 8 is pi over 2. So the lower limit of the integral is still 0. The upper limit of the integral, instead of pi over 8, it is pi over 2. This 4 in the denominator is like a 1/4, getting pulled out of the integral, and the integral of cosine u du, and u runs from 0 to pi over 2. So 1/4. Antiderivative of cosine is a sine, and it should be evaluated at these limits of the integral. This function evaluated at pi over 2, 1/4 sine of pi over 2 minus 1/4 sine of 0. As you know, a sine of 0 is 0, so this term is just 0. And sine of pi over 2, as you know, it is equal to 1. So sine of pi over 2 is 1. 1/4 times 1 is just 1/4. So the answer to this integral is 1/4. So please pay attention that in the indefinite integral cases, we needed to go back to the original variable x. But for the definite integral cases like this, we don't go back to the original variable x, or whatever the original variable was. We just change the limits of the integral according to the substitution that we used. And we come up with the final answer.